The photoelectric effect is a phenomenon in which electrons are emitted from a material, usually a metal, when it is exposed to electromagnetic radiation, typically in the form of light or ultraviolet radiation. This emission of electrons occurs only if the incident radiation has a sufficiently high frequency or energy, regardless of its intensity. To demonstrate the photoelectric effect experimentally, you can set up the following apparatus. Photoelectric cell. Use a photoelectric cell, also known as a phototube or photodiode, as the primary component of the experiment. The photoelectric cell consists of a vacuum tube with a cathode, negative electrode, and an anode, positive electrode, separated by a small gap. The cathode is typically made of a photosensitive material, such as cesium or potassium, which emits electrons when exposed to light. Light source. Use a light source capable of emitting electromagnetic radiation with a range of frequencies. This could be a monochromatic light source, such as a laser or a light-emitting diode, LED, or a broad-spectrum light source, such as a mercury vapor lamp or a xenon lamp. Power supply. Use a power supply to provide a bias voltage between the cathode and the anode of the photoelectric cell. This voltage creates an electric field that accelerates the emitted electrons towards the anode. Amplifier and meter. Connect an amplifier and a meter, e.g., a voltmeter or ammeter, to the output circuit of the photoelectric cell to measure the current or voltage generated by the emitted electrons. Experimental setup. Set up the photoelectric cell in a dark enclosure to minimize interference from ambient light. Connect the light source to the photoelectric cell, ensuring that the incident light is directed towards the cathode. Adjust the intensity and frequency of the incident light using appropriate controls on the light source. Data collection. Gradually increase the intensity of the incident light while monitoring the current or voltage output of the photoelectric cell. Note any changes in the current or voltage as the intensity of the incident light varies. Repeat the experiment with different frequencies of incident light, keeping the intensity constant. Observations. If the incident light has a frequency above the threshold frequency for the photosensitive material, you should observe an increase in the current or voltage output of the photoelectric cell as the intensity of the incident light increases. If the incident light has a frequency below the threshold frequency, no electrons will be emitted regardless of the intensity of the incident light. By conducting this experiment and observing the relationship between the intensity and frequency of incident light and the current or voltage output of the photoelectric cell, you can demonstrate the key aspects of the photoelectric effect, including the threshold frequency and the dependence of electron emission on the frequency of incident light.